Oh hey guys! You guys ready to get into some real heavy stuff? Then let's have a look at a legit redox reaction. Sounds like fun, huh? Alright then, let's go. Okay, so before things really take off, here's a little warning. If you're completely clueless when it comes to redox reactions, then it might not be a bad idea to check out this video right here first. I mean, it'd be really useful if you actually knew what we're talking about here, huh? Okay then, let's get to our redox reaction. So what we're going to show you here is a redox reaction between iron 2 sulfate and potassium permanganate in an aqueous solution. Let's start at the very beginning. First, our reactants. We're going to be working with an aqueous solution containing KMnO4 and FeSO4. Both of these are salts, so they dissolve in water. Then we're going to keep working with the iron 2 and the permanganate ions. And what are the products of the reaction? Well, the permanganate gives us the manganese 2 ion. This has to do with the fact that the solution is acidic, which means we also have to keep pH in mind when looking at redox reactions. If you want to know more about pH dependence, check out our video on the topic. And what happens to the iron? Well, our iron 2 becomes iron 3, and those are the products of the reaction. Now let's look at how we actually get these products. The first thing we need to do is determine the oxidation state of both the reactants and the products. Let's start with the permanganate. So oxygen has an oxidation state of -2. There's 4 of them, and the whole molecule is just negatively charged. According to the rules for determining oxidation state, that means the number for our manganese here is going to be +7. The oxidation state for Mn2+ is already determined by its charge, which gives it a charge of +2. Now on to the iron. It's really simple here too. Fe2+ has an oxidation state of 2+ and Fe3+ of +3. Good stuff. Okay, now for the partial equations. First, the reduction. Reduction is where we're going to be gaining electrons. So we're going to be looking for those substances where the oxidation state is getting smaller, like here where the permanganate is giving us manganese 2. We can see that the oxidation state of manganese is getting reduced, from +7 down to +2, which means we're going to be picking up 5 electrons. Now make sure you're maintaining mass balance. One more thing to look out for, O2- doesn't like just hanging out like that, so we're going to want to combine it with hydrogen to make water. But how easy is that? Pretty easy. You see, the problem's telling us we're dealing with an acidic solution. That is, a solution that is rich in H+. So our equation's going to look like this. Sweet! Okay, now for the oxidation. Here we have iron 2 getting oxidized to iron 3. This equation is obviously an easier one. Iron 2 gives us iron 3 and 1 electron. And the equation can just stay as it is. Then, the last step is going to be the redox reaction, where we're going to go ahead and combine our reduction and our oxidation reactions. And to make sure the whole thing is balanced, we need to make sure we have the same number of electrons on both sides of the equation. So we're going to multiply the oxidation reaction by 5. And that gives us a redox reaction that looks like this. Then we just cancel out the electrons on both sides and we've solved the problem. So what did we just show you? Well, what we just showed you is a pretty hard redox reaction. Potassium permanganate and iron 2 sulfate in an acidic aqueous solution. Solving this problem, the thing you should understand is that a redox reaction always happens the same way. You always have the reduction and the oxidation processes happening together at the same time. And the surroundings have a part to play too. Is the solution acidic, neutral, or basic? In redox chemistry, the answer to that question helps answer several other ones. The most important thing here, though, is that you can keep your cool, even when they throw a difficult problem your way. All these problems are solved in the exact same way, and by now, you should have it down pat. Well, I hope we've been able to make difficult redox problems look a bit less scary. If you want to know more about redox chemistry, just have a look at the videos in our playlist. Adios, guys, and have fun!